today we're going to talk about addition reactions. We're done with aromatic substitution reactions. Addition reactions are usually seen or experienced with molecules having unsaturation. But as we have discussed aromatic system before this, and you saw that it usually undergoes substitution reactions rather than addition. There's a special reason for that because of the fact that those molecules are aromatic. Addition would disturb the aromaticity, and that is why they are reluctant to undergo addition reactions. But apart from that, if you have any unsaturated system, like for example, you have an alkene, you have a conjugated diene, you have an alpha beta unsaturated system, you have an alkyne, such type of molecules can undergo addition reactions. We will discuss addition reactions in alkenes, and we will see how addition can occur on the carbon-carbon double bond. Addition to the double bond or addition across the double bond of alkenes could be both electrophilic as well as nucleophilic. So you would see that an electrophile can react with these alkenes, as well as a nucleophile can also react with these double bonds in different types of alkenes or dienes or polyenes or unsaturated carbonyl systems. Electrophilic addition to alkenes would mean that the alkene itself will act as a nucleophile, and anything that is coming outside from outside will act as an electrophile, which means that the alkene will act like an electron-rich species. The pi bond or the double bond of the alkene would act like a nucleophile, would be providing electrons to those electrophilic species. On the other hand, nucleophilic addition would mean that a nucleophile comes and it adds across the double bond of the alkene. In that case, this alkene or the double bond would act like a receiver of the electrons from the nucleophile. So we will see both of the cases, and we will see in what are the structural features that are responsible for alkenes being electrophilic or nucleophilic. So what happens is that in electrophilic addition to alkenes, we will first discuss electrophilic addition, and later on we will discuss examples in which the alkene itself is an electrophile while a nucleophile comes from outside and it attaches or adds across double bond. Actually, the pi electrons, the pi bond of the carbon-carbon double bond, that is involved. We have already discussed the reactivity order, and I've told you that if you have a sigma and a pi bond, mostly or always the pi bond will react because these electrons are more loosely bound between the carbon atoms. Right? So what happens as a result is that the reaction starts with the addition of the electron or of the electrophile on one of the sp2 carbons. There are two sp2 carbons involved in a carbon-carbon double bond. So the electrophile adds or it attaches to one of the sp2 carbon, and it concludes with the addition of a nucleophile to the other sp2 carbon. तो पहले जो reaction का start है, that will be initiated by the double bond or the pi electrons. They will attack the electrophilic part of the molecule. Actually, in addition, a whole molecule is added across. Yeah, part of two molecules are added across the double bond on the two sp2 hybridized carbons. So the pi electrons from between these two sp2 hybridized carbons, they will attack the electrophilic part of the molecule first, and that will leave these carbons electron deficient, which will allow the nucleophile to attack the other sp2 carbon. We will see that in the mechanism later on, but this is how the reaction proceeds. The reaction is initiated by the attack of the pi electrons of the sp2 carbons on the electrophilic part or the electrophile. So what is the end result? The end result is the breaking of the pi bond. As I told you that that double bond is converted into a single bond with the formation of new sigma bonds. So as I told you here that this new sigma bond and this new sigma bond is formed, and this pi bond breaks now between the sigma bonds that formed between the sp2 carbons, which of course now are sp3 hybridized, and the electrophile and the nucleophile, because a double bond has been converted into a single bond. So now the geometry around these carbons would be tetrahedral. So this is a general mechanism. For example, you are going, or you are desirous to add this whole molecule across this carbon-carbon double bond. This is an alkene. You can draw the bonds, the hydrogens or the alkyl groups, whatever is attached like this, right? But if this shows a carbon-carbon double bond. So you want to add this whole molecule across this carbon-carbon double bond. So as I told you earlier that the reaction starts by the attack of the pi electrons on the electrophile or the electrophilic part of this molecule, right? So the electrophile will get attached first, and later on this nucleophilic part will attack the second sp2 carbon and form this molecule. So you see that these two parts of this molecule, they attach to separate carbon atoms, adjacent carbon atoms. So these groups or the molecule as a whole, it adds across the double bond.